So geometry focuses on shapes. Algebra deals with solving things like equations. So one of the best explanations I will give for what is geometry is a topic called special triangles. Special triangles, there are two types of special triangles. But of course with geometry, you're dealing with shapes like triangles, you're dealing with shapes like square, circles, how do they behave? So that's what geometry is about. And that's why you can technically do geometry and algebra at the same time. So my recommendation is actually that people do algebra, and let's say they're doing algebra throughout a year, and they also do geometry at the same time, because there are two different branches of mathematics, and I think that's a much better use of everybody's time. So do algebra 1 and algebra 2 in parallel, right? So let's say you do these two over 1 year or 2 years, but then do geometry and trig at the same time, also at the same. So basically, this is a new model that I think will fit better for American students. And anybody, learn algebra 1 and 2 completely over 12 months, learn geometry and trig completely over 12 months. This normally takes 4 years to do. Amos is saying you should do it in 1 year. And basically, this is very doable. It's not too much to ask anybody, but we can discuss the strategy later. The idea is that algebra 1 and algebra 2 have a lot of overlap. So why don't you do them together? And then geometry has topics like find the area of a rectangle, right? Which is length times width. I mean, the idea of just plugging in the value for the length and the width to give you the area, that's using algebra in action. So you are doing them at the same time where you're learning the tools for algebra and applying it to geometry. This will revolutionize, I think, math education, because now you have a context for what you are learning, right? So this is pre-calc also, by the way. So that means that if I meet somebody in 8th grade, they can do what I have described over here. And so in 9th grade, they do calculus and statistics. So this same logic I'm giving that I've listed here, we can use it for calculus and statistics in 9th grade, which means that you have more opportunities to explore careers in 10th, 11th, and 12th grade because you've taken all the math that is necessary. So basically, we're going to go from 5 to 6 years of maths to bring it down to 1 to 2 years. And that's part of what AI can do, is that it can accelerate how much math a person can learn in 1 year. Okay, so now let's talk about special triangles, which I love. So special triangles is a topic that focuses on if you have a shape like this. Let's actually start with this one. If you have a shape like this, we call it an equilateral triangle because the side lengths are all the same, 2, 2, and 2. But that means the angles here are also all 60-degree angles, right? So this is called an equilateral triangle. An equilateral triangle has equal sides, equal angles in this case, right? And we can split this in half. So now we're going to take this shape. This was originally just one triangle. And we're going to extract this side of the shape that I called A. When we extract it, we now have this angle that we split in half, we bisected it, it's now 30. This angle is still 60. And the last angle there is 90, okay? So that's 90 degrees. So basically it's called a 30, 60, 90 triangle. So you have 30, 60, and 90. This triangle is called a 30, 60, 90 triangle. The side length is 2 over here. The other side length is 1 over here. And we don't know what that side length is. This is kind of the beginning of geometry, right? Some of the geometric thinking. I'm going to add one more slide because I want to explain how to use Pythagoras theorem to solve for the missing side. So this is geometry in action. Give me 1 second. So we're going to add one more slide on top of this. Okay, so imagine that triangle I showed you, this is 90, this is 60, this is 30. This was 2 and this was 1 because we sliced it in half. We call it we bisected it, right? So because we bisected the angle, we basically have 1 on the bottom instead of 2. Because remember, originally it was 2. The whole thing was 2. So that means this is 1 and this is 1 and then this is 2, of course, right? So here's the thing with geometry. In geometry, you learn about something called the triangle angle sum theorem. The triangle angle sum theorem. What the triangle angle sum theorem is saying is that the angles of a triangle, let's call it A plus B plus C, the three angles of a triangle will add up to 180 when we're dealing with a triangle. So that's geometry. It's the idea that the angles of a shape can be determined by a specific formula. The sum of angles of a shape, n minus 2 times 180. So 3 minus 2 times 180. 1 times 180, which is 180, right? So the formula for the triangle angle sum theorem, or the sum of angles of a shape, is take the number of sides of the shape, subtract 2, and multiply by 180. So you get 180 degrees, okay? So that is the triangle angle sum theorem. So that's how we get 30, 60, 90. So this is called a 30, 60, 90 triangle. We're going to build on this over the next few weeks. But there's one more type of triangle here where you have a square, and with a square, with all the sides being equal, you have all the angles are 90 degrees in the square. So we can take the same logic I did before, and we're going to split this shape into two. This is going to be called A, and this is going to be called B. For the part that is called A, because I split it into two, this is 45, this is 45, and this is 90. Again, in geometry, we're basically taking a theorem, we're applying it to this principle. So for a square, what is the sum of angles of a square, right? It's 4 minus 2 times 180. Now you use PEMDAS. So notice now you're using pre-algebra because you have to do the parentheses first and then times 180, right? So this becomes 2 times 180, which is equal to 360 degrees. So the sum of angles of a square is 360 degrees, which makes sense because we had 90, 90, 90, 90. See, geometry is about how to think, logic, how to reason. That's a lot of geometry. That's why you can be doing algebra at the same time that you're doing geometry, because you're using different aspects of reasoning, right? Okay, so that's a movement we're going to start. Algebra, geometry, movement. Let's do them together at the same time. Okay, so now we don't know this missing length, and I want to introduce you to a concept called the Pythagoras theorem. The Pythagoras theorem basically says that if you have a triangle, if you square the lengths of each of the legs of the triangle, they will equal the hypotenuse. So this is called A, this is called B, and this is called C in my particular case. So that means it's going to be, if this is A and this is B, you now plug it into the formula. 1 squared plus 1 squared is equal to C squared. So then it becomes 1 plus 1 is equal to C squared. Okay? So that means 2 is equal to C squared. But if I'm looking for C, I have to take the square root of both sides. So C is equal to the square root of 2. We have found this missing length as the square root of 2. Now, that's a lot to chew on. But the point is, geometry teaches you how to work with shapes, come up with theorems, and that's what we're going to discuss. So right now I've shown you how to find the missing side of a triangle, the leg of a triangle, using Pythagoras theorem. Who was Pythagoras? Pythagoras is one of the most famous mathematicians of all time. He lived around 500 BC, which would have been around the time that Daniel, the prophet in the Bible, lived. Pythagoras was a sort of a Greek mathematician, and he did a lot of things that we still do and talk about today. Now, Pythagoras' theorem, people argue that it also was used by the Babylonians, and that's a good point. So the Babylonian civilization has a mark on mathematics. When you talk about 60 seconds, 60 minutes, this 60 idea, that's going back to the Babylonians, right? So what we're going to do, and I'll stop here for a second, is we're going to take, and actually for time purposes, I'm going to fold this up, and I want to show you one thing. We're going to take math and history, and we're going to line them up on the same timeline. So for example, in history, we say the Babylonians. And now we need to talk about what is the math that the Babylonians gave us. And then we're going to talk about the Chinese. And we're going to talk about the Indians. And basically, the goal is you should be able to look at the history of the world and the history of math and science, and you should be able to line things up. So when I say 500 BC, you should be able to tell me, okay, so Pythagoras people came around that time. This is part of what we'll do in our journey. But let me pause. That is geometry.